Okay, guys, so we left off right at the bottom of the notes here. Before I finish up with those, I just want to go back a little bit. Again, just going through this section here about adding and subtracting, multiplying and dividing positive numbers. Remember that when you go through this process, those actions don't affect your inequality symbol. Okay, so you're acting as if you're just solving a normal equation. You're trying to solve x, try to find your variable. Nothing changes your inequality sign except when you multiply or divide by a negative number. Okay, we went through this whole process here, solving for these different answers here. So when we get down to multi-step inequalities, again, I know I went through this one with you. You're just following that same process of solving, right? Unless you're multiplying or dividing by a negative number, nothing is changing about your inequality symbol. It stays consistent. So here we add 5. This cancels. We get 2x is less than or equal to 28. And when we divide, because I'm dividing by a positive number, because this 2 is positive, when I divide, I get x is less than or equal to 14. So again, when we graph it, we plot our number. If I have the less than or equal to symbol, my circle on 14 is going to be closed. Remember, every time you have to take that extra step to draw the line under your inequality, you have to take the extra step to draw a color in your circle. And if x is less than 14, if x is smaller, our line is going towards the left there. Okay, so the process itself of solving should be fairly simple, should be fairly familiar for you guys. It's just that one rule of if you're multiplying or you're dividing by a negative number, then you have to switch your inequality symbol. But what we want to talk about, this is what I wanted to get to that we didn't have time to today. What we want to talk about is special situations. So for some multi-step inequalities, we may have a case where there are infinite solutions. For our inequality. Or we may have a situation where there's no solution to the inequality. So what that means is if I have infinite solutions, it doesn't matter where my number sits on my number line. I could think of any number at all. And when I plugged it into my inequality, it would always prove my inequality to be true. If there was no solution, there is absolutely no number out there that exists where I could plug that number in for x, that would make my inequality true. Every single number that I plug into the inequality would end up being false. So if I want to see how those situations would look when I solve an inequality. So here, first thing we'd have to do would be expand this right side. So we're going to distribute the 7. We're going to get 14x plus 5 is less than 14x minus 21. Now, if we notice, we have an x on both sides, but when I go to bring the x over to the same side, 14x minus 14x cancels. Same thing here. So what I'm left with is an inequality that says 5 is less than negative 21. This is not true, right? 5 is not smaller than negative 21. Because this is not true, this is a situation where we would see no solution. Okay, so your special situations occur when your x's completely cancel, when you're trying to get them on the same side and they completely cancel and they go away. Since there is no solution and we talk about graphs representing the solution, our graph, our number line, is just going to be a blank number line. Okay, over here, we would still distribute that 6. We would get 12x minus 1 is greater than 12x minus 6. Again, we'll see that when we try to get the x over the same side, both of these cancel. And now we're left with the inequality negative 1 is greater than negative 6. This is true, right? Negative 1 is bigger than negative 6. It's further to the right on the number line. So this is a true inequality. If you have a true inequality where your x's or your variables cancel out completely, this is where you would have infinite solutions. Okay, so every single number you could possibly think of, whether it's 3,542 or whether it's -1. If I plugged both of those numbers into this inequality, it would always prove to be true. So if I'm representing all my numbers, infinite numbers being my solution, my graph, it covers every single number on the number line. Okay, that's about it for this section. So that was chapter 5, section 1, 2, and 3. I think, as I said, because you guys are so familiar solving regular equations, that solving these inequalities shouldn't be too different for you guys. It's the same process. It's just remembering our simple rule here. Other than that, the only new information I would assume that you haven't seen is graphing these on the number line. So just remember to keep your circles straight. Make sure you know which when you use a closed circle versus when you use an open circle. And make sure you understand where your arrow is moving and why it's moving in that direction.